Hey, Clark. Good afternoon to all. Am I audible? Someone just message in the chat box so that I will be able to understand that my voice is audible. Okay, I'll start the session. Today we'll discuss RL circuit, to which the supply is AC supply, and when AC supply is given to the RL circuit, so what will be the response and solution using differential equation method. We'll discuss about. Okay, so we are going to use differential equation method to determine the response and solution for an RL circuit with AC supply. So now let us consider series RL circuit. So resistor and inductor, they are connected in series, and there is a switch which will close at t equal to 0, and the supply AC supply is V of t is equal to Vm sin omega t plus phi. Okay, this is phi. This should be somewhat like this. This is phi symbol. This is symbol of phi. Okay. So this is our input. So when switch is closed, the response in the circuit is I. I is our response. And initially let us assume switch is closed and let us apply Kirchhoff's voltage law to the given circuit. So what do you get? So apply the algebraic sum of all voltages, only one voltage source is there. So Vm sin omega t plus phi. Vm sin omega t plus phi. This is phi. Okay. My cursor won't listen to me and okay, whatever. So Vm sin omega t plus phi is equal to R into I plus L into di by dt. So this is KVL equation for this circuit. So instead of simply listening, it's better if you people are able to write it down. And how to follow this session, better if you are writing it down in your notes. I hope you are writing. So it is Vm sin omega t plus phi is equal to Ri plus L into di by dt. Just divide both sides with L. So if you divide both sides with L, what do you get? Di by dt plus R by Li is equal to Vm sin omega t plus phi by L. Consider it as your equation number 1. Now you just look at this equation carefully. So what are all the terms that are there in your equation 1? Di by dt plus some constant into I, that is equal to, this is some constant, let us assume. So this is looking like a non-homogeneous equation with the p value, R by L and k value. K value Vm sin omega t plus phi by L, where I is our variable. So I is x. Yeah, I is nothing but x. So you can compare equation 1 with non-homogeneous equation. So I hope you might have written. I'm changing this slide. So compare it with the non-homogeneous differential equation. What is it? What is our non-homogeneous differential equation? Dx by dt plus px is equal to k is our non-homogeneous differential equation. And the solution for this non-homogeneous differential equation is x of t is equal to xcf plus xp. So xcf means complementary function, and this is our steady state value or particular function. Okay. Complementary value and particular value, or we can say complementary function and particular function. So the solution of this non-homogeneous differential equation will have two parts. One is complementary part, other one is particular part, or one is transient part, other one is steady state part. Okay. So you just compare equation 1 with this non-homogeneous equation. So what will be the solution for equation 1? Solution for equation 1 is x means I. So I of t is equal to xcf means ICF plus xp means IP. That's it. So current will have two parts. The current in equation 1 will have two parts. One is complementary part, other one is particular part. Okay, just write it down quickly. So now let us see what is the complementary part solution. Complementary part, is given by C e to the power of minus Pt. Okay, ICF is our complementary current, that is given by C e to the power of minus Pt. What is P value? P value is what? What is P value? P is R by L. So, where is it? Yeah. Instead of P, you can write R by L. So, what is our complementary part? Complementary part, ICF is equal to C e to the power of minus R by L into T. Okay. So, we have got some expression for the complementary part of the solution. Now, next part of the solution is particular part. So, particular part formula is what? IP is equal to A cos omega t plus phi plus B sin omega t plus phi. So, consider this particular part of your solution as equation number 2. Okay. So, particular part solution is what? So, particular part of the solution. So, it is IP equal to A cos omega t plus phi plus B sin omega t plus phi. Okay, so consider it as equation number 2. Now differentiate this particular part of the solution, d by dt of ip. So let us give some notation. D by dt of ip as I dash p is nothing but d by dt of ip. So just differentiate this equation 2. Okay, differentiate this equation 2, you will get minus a omega sin omega t plus phi plus b omega cos omega t plus phi, and consider it as equation number 3. Okay, so whatever expression is there for this particular solution, for that expression you just differentiate that expression with respect to time. Okay, you will get this equation number 3. Now substitute ip and ip dash in your equation 1. Okay, so what is our equation 1? What is our equation 1? This is our equation 1. What is it? D by dt of I. So just now we have determined d by dt of ip, and we already have ip. So consider this as ip and consider this as d by dt of ip. So substitute, okay, consider this as ip and consider this also ip. So d by dt of ip just now we have calculated. Ip value also we have an expression for ip. So you just substitute this ip and d by dt of ip in this equation 1. So you will get this one. Okay, so what is it? D by dt of ip you see here, minus a omega sin omega t plus phi plus b omega cos omega t plus phi plus r by L into ip. Ip is what? A cos omega t plus phi plus b sin omega t plus phi equal to Vm sin omega t plus phi by L. Okay. Consider it as equation number 4. Consider this as equation number 4. Now, in this equation, it's better if you multiply r by L with this term and these two terms. If you multiply, it's better. And if you write one more expression, it will be good. I didn't write here, but if you want, you can write it. Now, let us compare the coefficients of sine. Coefficients of sine in this equation number 4. Okay, in this equation number 4, let us compare the coefficients of sine. Where is sine? This is sine, isn't it? Its coefficient is minus a omega. Okay, I will erase and once again I will select. So coefficients of sine, one coefficient of sine is minus a omega on the left side of the equal, and one more coefficient of sine is b into r by L. Okay, and on the right side coefficient of sine is Vm by L, isn't it? Coefficient of sine is Vm by L. So see here, I have along with the sine omega t plus phi I have written. No need to write this. No need to write this. Simply you can write the coefficients. So what are all the coefficients of sine? Minus a omega plus b R by L equal to Vm by L. You just, if you are writing it down, you can copy as quickly as possible. I hope you might have written. Now let's compare the coefficients of cosine values. Okay, coefficients of cosine values. Coefficients of cosine values, what are those? B omega is one coefficient. Another coefficient is A into R by L on the left side. Right side there is no cosine, so right side it is 0. So B omega plus A into R by L is equal to 0. So consider this as equation 6. Coefficients of sine, consider it as equation 5. Okay. So we have got, just comparing the sine coefficients and cosine coefficients, we have got expression 5 and expression 6. Okay, equation 5 and equation 6. Now from equation 6, you can determine some term either A or B. I have determined B in terms of A. B is equal to minus A R by L omega. Okay, just rearrange these terms. From equation 6, determine B value. B you will get minus A into R by L omega. You will get, consider it as equation number 7. Now I know A in terms of, B in terms of A. Now I can substitute this 7 in equation number 5. In the equation 5. If you substitute 7 in 5, okay. So substitute here B is there. Instead of B you write A minus A R by L omega. If you write that, you will get, what do you get here? Minus A omega minus A R square by omega L square equal to Vm by L. Okay, consider it as equation number 8. If you are writing it down, write quickly. I hope you are able to follow till now. Okay, so if you are carefully listening to the session, you will be able to follow, otherwise it is not possible. So all these transients are important. Okay, now, so from this, if you observe here, there is a term, unknown variable is a, only a is there. Okay, so you can just modify this and you can determine a value. What is a? Simply rearrange the terms in your equation 8, you will get equation 9. What is A? A is equal to minus Vm omega L by omega square L square plus R square you will get. Now substitute this 9 in your equation 7, you will get the B value. So B is equal to Vm R by omega square L square plus R square. So consider it as equation 10. Now you have got some value for A and you have got some value for B. Now you can substitute that A and B in your particular value solution current. Okay, particular value of means the solution value. Okay, the solution of the current had two parts, one complementary part, another one was particular part. So in the particular part of the current solution, you can substitute A value and B value. IP is equal to, okay, you will get minus Vm omega L by omega square L square plus R square into cos omega t plus phi plus Vm R by omega square L square plus R square sin omega t plus phi you will get. Consider it as equation number 11. Okay, so this is the particular solution for the given non-homogeneous equation that you have obtained by simply rearranging the terms of your KVL equation for the RL circuit. Now this expression, if you see this equation number 11, it's very lengthy expression, isn't it? It has many terms and it is very lengthy. IP equal to minus Vm omega L by omega square L square plus R square into cos omega t plus phi plus Vm R by omega square L square plus R square sin omega t plus phi. So let us simplify it. Okay. Let us simplify it. For that, let us assume this whole term is, let us replace this whole term with some smaller term with some other notation, and let us replace this term also with some other notation. Okay, in your next slide, I will show you that. So, here I have assumed some m sine theta is equal to minus Vm omega L by omega square L square plus R square. Okay, so I have replaced this minus Vm omega L by omega square L square plus R square with m. I have replaced it with m sine theta. Okay, similarly, you can replace this whole term with m cos theta. Okay, you can replace it with m cos theta. That's what I have written in the next slide. So m sine theta, let us assume m sine theta is equal to minus Vm. Okay, I will take the laser. Huh? No, it's better to take the cursor instead of laser. Okay, so m sine theta is equal to minus Vm omega L by omega square L square plus R square. Consider it as equation number 12. Similarly, m cos theta is equal to Vm by R. I'm sorry, Vm R by omega square L square plus R square. Consider it as equation number 13. Okay, now you can substitute 12 and 13 in your equation number 11. Okay, so you'll get a simple expression for a particular solution of the current, that is IP is equal to m sin theta cos omega t plus phi, m cos theta sin omega t plus phi. Okay, this is more simple. Number of terms have been reduced. Okay. Now, here you can take m common. You can take m common and rewrite this expression. Take m common and you will get IP equal to m into sin omega t plus phi cos theta plus cos omega t plus phi sin theta. Okay, so I have simply rearranged the terms, means I have written this term first and later I have written this term. Why? Because I want to further simplify this expression, that's why. So this is looking like sin A cos B cos A sin B. Okay, so this expression sin A cos B plus cos A sin B. So it can be replaced by sin A plus B. What is A value? Omega t plus phi. B value is theta. Okay, A is equal to omega t plus phi and B equal to theta. So sin A plus B. So this is A, this is B. Okay, so IP I have got a very small expression here. The expression is IP is equal to m sin omega t plus phi plus theta. So consider it as equation number 14. So we have got some simpler expression, but we don't know what is meant by m. We took some notation here, m as, okay, m notation, but we don't know what is the value of m and we don't know what is the value of theta. Okay, so we don't know m value and theta value. Let us find m and theta in the next slide. So till now we have got an expression for the particular solution of current IP, that is equal to what? M into sin omega t plus phi plus theta. Let us determine this theta value and m value. So for that, to find m value and theta value, I have considered a triangle, okay, whose hypotenuse is m. If m is the hypotenuse, this is a right angle triangle with angle theta, okay, then this is our m sin theta, this is our m cos theta. Okay, And similarly, I have considered one more triangle which is known as impedance triangle. In this impedance triangle is for RL circuit. The base is R, opposite is omega L, and hypotenuse is Z. Okay, so M sin theta and M cos theta are there. So for this first triangle, M sin theta is the opposite, M cos theta is the base. So M sin theta by M cos theta is nothing but tan theta based on what is tan theta? Opposite by base, isn't it? Tan theta is opposite by base. So it is nothing but M sin theta by M cos theta is nothing but tan theta. That is equal to, from the impedance triangle, what is opposite? Omega L. What is base? R. So that is equal to omega L by R. Okay, tan theta is equal to omega L by R. Here I have written minus. So from the impedance triangle, you can never write, you won't be able to write the minus or plus symbol. Okay, so why I have written minus? The reason behind that is current. Okay, current lags voltage. Okay, current lags voltage by some angle. Okay, so since current is lagging here in RL circuit, so current I phasor lags. So I can't write. Okay, if it is a purely inductive circuit, the current will lag by an angle of 90 for purely inductive, but it is not purely inductive, isn't it? So I must draw like this. This is I and this is V. Okay, and this is theta. This is the phasor relation between voltage and current. So this is, if this is voltage vector, this is current vector, this is the phase angle theta between V and I, then current lags voltage. So whenever current is lagging voltage, okay, you can mention minus symbol. So tan theta is equal to minus omega L by R. Why minus? Why? Because current is lagging voltage by some angle theta. Okay, so I hope you are able to follow. Okay, so if tan theta is equal to minus omega L by R, so what is theta? Theta equal to tan inverse of minus omega L by R. Consider it as equation number 15. Consider it as equation number 15. Now, from this triangle, okay, from this triangle, what is hypotenuse? M square is equal to M square sin square theta plus M square cos square theta. Means M equal to root of M square sin square theta plus M square cos square theta. So that's what I have written. M equal to root of M square cos square theta plus M square sin square theta from this triangle. You'll get this expression. Okay. So we have determined some expression for theta, some equation for theta. That is our equation number 15. Now we have to determine M value. So M is equal to this. So M is equal to what? From this triangle, M is equal to root of M square cos square theta plus M square sin square theta. Now we already wrote some expression for M sin theta and M cos theta. That is our equation 12 and 13. So from substituting equation 12 and 13 in this equation, okay, equation 12 and 13 in this equation, and simplifying it, okay, substituting in this equation and simplifying it. So I have written 12 and 13 in equation 5 I have written. No, it's not. Equation 15 I have written. It's not 15. So 1 second. Not in 15. Should be in the above equation. I will write in the above equation. Otherwise I have to change all the notations in the next slide, from next slide onwards. So in the above equation for that. Okay, I'm not giving any notation because I have already assigned numbering. I have given numbering to each and every equation. If I give some numbering, I can give 16, and I can write substituting 12 and 13 in equation 16. Then I have to change the numbering for all the other slides which are and which I have numbering of all the other slides in the next slide, from next slide onwards. So simply I have written substituting 12 and 13 in the above equation and simplifying it. You just substitute that and simplify, you will get this expression 16. Okay, you will get 16. Some expression for m value. So m is equal to Vm by root r square plus omega um, L whole square you will get. Now substitute this m and theta value. Theta is expression 15. Theta and m that you have got in x16. Substitute this in your equation number 14. So IP will be particular value. So particular solution of the current, that is IP is equal to Vm by root r square plus omega L whole square into sine omega t plus 5 plus, instead of theta must write tan inverse of minus omega L by r. Okay, so tan inverse of minus omega L by r is nothing but minus tan inverse of omega L by r. That's what I have written in the next equation. So this term, it is modified and you will get this. So this is our equation number 17. Okay, so this mathematical simplification is easy. If you are carefully listening to this session, you will be able to follow. So you have got an expression for the particular solution. IP is equal to Vm by root r square plus omega L whole square into sine omega t plus 5 minus tan inverse of omega L by r. So you have an IP expression, you have complementary function expression. So what is our current I of t? I of t is equal to C e to the power of minus r by L t plus IP is what? Vm by root r square plus omega L whole square into sine omega t plus 5 minus tan inverse of omega L by r. So consider it as equation number 18. Okay, so this is the response for the given RL circuit when AC supply is given. Now we didn't consider the initial conditions, isn't it? Let us consider the initial conditions. So let us assume at t equals 0 plus, which is closed. Okay, so at that time current in the circuit is 0. So substitute the initial conditions. If you substitute initial conditions in equation 18, current will become 0. Wherever time was there, substitute 0. T is 0, T is 0. Okay. So wherever t is there, substitute 0. Wherever I is there, substitute 0. So this is 0. My cursor won't listen to me. Okay. So this is 0. This time is 0. Here also t is there. That is also 0. So wherever t is there, substitute 0. Wherever current is there, substitute 0. So if you substitute current and time 0, you can determine. Why do we implement initial conditions? Our main aim is to find the arbitrary constant C value. So to determine C, consider the initial conditions. Substitute t equal to 0 plus and current equal to 0. So if you substitute, you will get 0 equal to C plus Vm by root r square plus omega L square into sine 5 minus tan inverse omega L by r. Okay. So C is equal to what? C is equal to minus Vm by root r square plus omega L square into sine 5 minus tan inverse omega L by r. Consider it as equation number 19. If you are writing it down, you just write it down quickly. Okay, now substitute this C, that is 19, in your equation number 18. Okay, substitute 19 in equation 18, you will get the response, okay, or the solution of current, that is I of t equal to minus Vm by root r square plus omega L square into sine 5 minus tan inverse of omega L by r. r into e to the power of minus r by lt plus Vm by root r square plus omega l square into sine omega t plus phi minus tan inverse of omega l by r. So this is the solution for the RL circuit. If you are copying it down, just write it down. So if you are attending this session and if you feel that you are unable to follow, that means that you are not carefully listening to this session or you have not attended these previous sessions. Okay. Now let us solve a numerical problem. So in this numerical problem, they have mentioned frequency of 50 Hz, 400 volts peak value is given for sinusoidal voltage. Okay, applied at t equal to 0 to a series RL circuit having resistor of 5 ohms and inductance 0.2 Henry. Obtain an expression for current. So we have to determine the current, that is response in the given RL circuit. And here sinusoidal voltage is applied, means AC supply is given. Okay, so and you have to calculate the value of the transient at any instant. Transient means complementary part. Okay, at any instant C. Okay, at any instant C, and current after 0.01 seconds after switching on. Okay, after turning on means after closing the switch. If the switch is slot closed at t equal to 0, if initially they have mentioned t is equal to 0, later we have to determine the transient if the switch is closed at 0.01 seconds. Now what is given? Frequency is given, that is 50 Hz. You just write it down. You just take a minute. I will wait. Okay. What else is given? R 5 ohms and L 0.2 Henry is given. Peak value of the voltage is given, that is Vm. Peak means maximum value. Peak means maximum value is given, voltage maximum 400 volts. So what is our sinusoidal voltage now? Formula is what? V equal to Vm sine omega t, or V of t is equal to Vm sine omega t, you can write. So Vm is what? Peak value is 400 sine omega t. Omega means 2 pi ft. So 2 pi ft means 2 into pi value is 3.14. F is frequency 50. So what is V? 400 sine 314t. Okay. So this is the input voltage. So our input voltage is V equal to 400 sine 314. Okay. So now you can draw the circuit. So I hope you might have drawn it. Now apply KVL to the above circuit and write down 400 sin 13t is equal to what? R into I plus L into di by dt. Consider it as equation number 1. Now just rearrange the terms. Divide both sides with L. So you will get di by dt plus R by Li is equal to 400 by L sin 314t. Okay. So after that, substitute L values and R values. R value and L values here. So if you substitute, what do you get? Di by dt plus 5 by 0.2. So means 50 by 2 means 25i is equal to 2000 sine 314t. Okay, I didn't simplify it further. Simply have written. So this expression, if you compare it with the non-homogeneous differential equation, it is somewhat looks like a non-homogeneous differential equation, isn't it? This is R by L, isn't it? This is R by L. That is R by L means this is our P and this is our K. I is our X. I is the X value. Okay. So it is similar to non-homogeneous differential equation. Therefore, what is the solution for the non-homogeneous differential equation? It will have two parts, one complementary part and one particular solution. So I is equal to I or I of t. What did I write in the circuit? I have written I. So better to write I. So I is equal to ICF plus IP. Okay. I is equal to ICF plus IP. And just now we have discussed the theory. So we know the formula for this I, that is I is equal to C e to the power of minus R by L into T plus Vm root R square plus omega L whole square into sin omega T plus 5 minus tan inverse of omega L by R. So we need not derive this expression because we have to solve the numerical problem. For the previous case, it was the theory, so we have derived this expression. So just now we have seen in the theory the equation for the solution of the current for when the given expression is in the form of non-homogeneous differential equation. Then the response will have two parts, one complementary part C e to the power of minus R by Lt and another part is steady state part, that is particular part, that is Vm by root R square plus omega L whole square into sin omega T plus 5 minus tan inverse of omega L by R. Okay, this is already there. If you are writing, this will be already, this will be there in your notes. Okay, so now substitute R value and L value in the above expression. Okay, R value and L value in the above expression. And omega also, omega is nothing but 2 pi f. F is 50. So substitute all those values and simplify. You will get I equal to C e to the power of minus 25t plus what is Vm? Vm isn't it? This Vm. These are Vm. Vm is 400. So 400 divided by root of I square plus 2 pi plus 0.2 into 50 whole square sin 314t minus tan inverse of 12.56 you will get. Okay, just simplify it further. You will get I equal to C e to the power of minus 25t plus 6.34 sin 314t minus 85.4. So here actually I have neglected 5 value. I forgot to tell you. I have neglected 5 because I don't know 5 values. So simply I have neglected 5. So neglecting 5, I have substituting omega value, L value, R value and Vm value, R, omega, L, here also R and L value. If you substitute and simplify, you will get this expression neglecting 5 value. So after neglecting 5, I have assumed 5 equal to 0. I have got this equation 2. So I is equal to C I is equal to C e to the power of minus 25t plus 6.34 sine 314t minus 85.4 you will get. Okay, so we have got an expression for current now. That is our equation 2. Now let us find C, which is unknown term here, isn't it? C is unknown term in equation 2. Let us find C. So in order to find C, that is arbitrary constant, we must always consider what? Initial conditions. So what is our initial condition? It's an RL circuit at t equal to 0 plus, which is closed. So current in the circuit is 0. Why? Because immediately when switch is closed, inductor acts as open circuit. So since inductor acts as open circuit, no current will flow through it. So wherever I is there in the above equation 2, I just substitute 0. So I is what? I is 0. And wherever t is there, substitute 0. So here also t is there, substitute 0. So wherever I and t are there, substitute 0 and simplify. Okay, substitute 0 and simplify. You will get 0 equal to C plus 6.34 sine minus 85.4 and sine minus 85.4. Its value is minus 0.997. So 0 is equal to C plus 6.34 into minus 0.997. So multiply these two terms, you will get C is equal to 6.320. That is our equation 3. We have got C3 means C value, that is equation 3. Substitute 3 in 2. Okay, substitute 3 in 2. Okay, so if you substitute 3 in 2, you will get current equation I is equal to 6.320 e to the power of minus 25t plus 6.34 sine of 314t minus 85.4. Now they have mentioned transient current at t equal to 0.01 seconds. Okay, this is the current in the given circuit. That's it. We have determined the current in the given circuit. One more part they have mentioned is that determine the transient current at t equal to 0.01 seconds. Means at, so what will be transient current? So what is our transient part in the above equation? This is transient part. Okay, this is our particular solution. Steady state part. Second part is steady state. Okay, this is steady state part. This is our transient part. So transient part. So they have asked us to determine the transient part at t equal to 0.01. So this current has two parts. It means one complementary part, another one is particular part. Complement is transient, particular part is steady state. So transient part current, only consider transient part from the above equation. So it is transient part is 6.320 e to the power of minus 25t. Now substitute t value here. What is t? 0.01. Substitute it, you have got transient current. So I transient is 4.92 amperes. Okay, so in the question they have mentioned that if switch is closed at t equal to 0.01 seconds, then the transient current that is flowing in the circuit is this. Just simplify t value, you will get this. Okay, that's it. I have discussed a numerical problem and how to determine the current for RL circuit. I'll close this session. and immediately I will start the next session. You just leave and rejoin the next session. Okay, leave this session and immediately join the next session. I will start the session quickly.